Morning, my name is Adam Ruemenapp. Today I'll be talking to you about one of my passions, how a flight can travel across the country simply, every day, and safely. Today I'll be explaining to you how Delta 1010 or 110 can go from Atlanta to Los Angeles and how the operation goes. These hyperlinks don't work, so I'll have to explain. The route, the pilots will show up a couple hours before the flight, probably about an hour and a half. If it's the first flight of the day, they'll go to the dispatching office, they'll get the route, the paperwork for the flight, fuel load. The first officer will then go to the aircraft, prep it, and the captain generally goes and briefs the flight attendants over the weather for turbulence and stuff like that. Pre-flight, the first officer generally performs a walk around. He's looking for, in this instance, the landing gear, looking for cracks, leaks, making sure the tires are inflated, making sure the struts are in good condition. Captain will go to the cockpit and generally set up basic components of the flight. If he's the pilot flying, which is actually the person that flies, the first officer and captain will generally switch each leg. In this instance, let's say the captain's flying, he would go to the cockpit, wait for the first officer to come back from the walk around after briefing the flight attendants. The first officer will then generally program the flight management computer, which is located here. He'll insert the route, which can, in this plane, since it's pretty advanced, it'll be sent from dispatching, then just hit a button, and it loads the entire flight plan performance calculations. An ATIS is the weather for the local airport. This one is for Atlanta. It can be read. This is the date, February 7th. It was provided at 3:52 Zulu, which is about 10:52 in Atlanta. It's plus 8 hours from the local 24-hour time. The wind is 090 at 4, which is 090 is a magnetic heading based around 360 degrees. 4 knots is roughly 4 miles an hour. Visibility is 10 miles. Ceiling is broken at 25,000 feet. Temperature is 12 Celsius. Dew point is 0. The altimeter is 3012. That'll be set up here on the control panel. And the altimeter located here, it'll read the altitude correctly with the difference in pressure. Standard pressure is 29.92 inches of mercury. Weather en route, it's crucial that the dispatching gets the weather fairly accurate. Obviously, forecasts are forecasts, so they do change. In this instance, our flight is flying, and it's encountered a cumulonimbus cloud, probably from a thunderstorm. They'll have to deviate around the route that they were supposed to fly, which will take more time and burn more fuel, so it's important that dispatching gets the route correct the first time. Airport diagram. This one would be for Atlanta. Again, the link doesn't work. But here's an overview of the airport. It's basically an overlay of the airport from a top-down view. It's black and white. It'll tell you the taxiways, ramp. So, for instance, this would be ramp 1. And you can see the runways would be, this is 9 left and 27 right. And again, they're all numbered based on magnetic headings. Basically just an overview of that so you can taxi around and know where you're going. SID, all international airports have several of these, especially Atlanta, as it's the busiest airport in the world. It's a standard instrument departure. It's a prescribed route that air traffic control will give you. Generally, you can know about it ahead of time. It does change. Dispatch will know, and they'll put in the route. This flight will use the Ramblin' 7 departure and the Gadsden transition, which Gadsden is a city located just outside of Georgia. En route, pilots will have general conversations with each other. Below 18,000 feet, there's a zero cockpit rule the FAA provides, so that they're just focused on the flight. But however, they'll monitor aircraft systems, monitor PIREPs, which are pilot reports, SIGMETs and AirMETs, which are significant weather en route. And then is there about 80 miles from the top of descent, which is probably about 150 miles from the destination. They'll start preparing for the arrival, and that is the STAR. Los Angeles has several of these. Generally, they're in a west flow, which means they're landing towards the west on 25 left and 24 right. This flight will use the CVU2 arrival on the 29 Palms transition, which is located in Eastern California. And this is just to maintain traffic flow and separation for the aircraft. Approach plates, these are instrument approach plates, which basically This flight will land on 25 left on an ILS, which is Instrument Landing System. They'll pull up the approach plate, look at it. They'll have a decision altitude, which here on this runway, it's 107 feet above the ground on the radio altimeter, which would be 207 feet since Los Angeles is 100 feet above sea level. And they'll get the frequency and the course, which they just plug in to the computer and frequencies and radio, and they'll just fly right to the runway. And they can do it in very limited visibility. Airport diagram again, we have Los Angeles. It's the same thing as Atlanta, just an overview of the airport. You have the east side or the south side of the airport. You'll have 25 left, 25 right, and over here on the north side, 24 right and 24 left. Generally, legacy carriers at LA park down here. It's their Delta. As a legacy carrier, will park here at Terminal 5 and 6. It'll land 25 left. Generally, again, that can change for air traffic reasons as far as volume of traffic. Arrival, plane will arrive at the gate and shut down everything. If they're turning the plane, generally a 777 won't fly like an hour later. It'll fly a couple hours later. This flight continues on to Sydney, so they'll probably shut down the aircraft and just shut down the APU, auxiliary power unit, engines, instruments, so saves battery power. And then likely the flight crew will change as it probably exceeded the Sydney to Los Angeles is like a 14-hour flight, so they'll have to get a new flight crew of 4 pilots for that flight. So they'll come and do the same things as setting up the aircraft as the first crew did. Post-flight paperwork, most pilots despise this. In this instance, it was a little bit more interesting. I know a captain at United who flies 777s. This flight was going from Dulles to Los Angeles. He talks about in this report how they encountered Madden wave turbulence, which is wind being forced up over mountain ridges, and it accelerates the air, causing the aircraft to slow down if it's flying into it. Coming back over the ridge, it'll probably cause the plane to accelerate. In this instance, they almost oversped the aircraft at VMO, which is maximum operating speed. That can cause the plane to break up in flight. However, this captain is very good, so he talks about how he turned off the autothrottle, which basically is the autopilot for the engines, which controls it. Talks about how he brought the throttles back to idle as they increased, limiting the aircraft from overspeeding. They didn't exceed it, but they came close. Then coming back over the ridge, talks about how they almost stalled, but he increased full power again. He talks about here they were at 120 knots, which is about 120 miles an hour, which is an indicated airspeed. And that changes. The higher you go, the faster that is, because it's indicated. It's just a measure of how much air is flowing over the wings at a speed. He talks about here how ATC allowed them to descend from flight level 370, which is 37,000 feet, down to flight level 350. And the flight landed safely. Passengers never knew. And that is how your flight gets across country safely. Thank you.